Hi, very good morning. This is Dr. Sajja Suneel from Data Science Department. Today I am going to tell you about the installation as well as the interfaces, which is a continuation for the previous topic. And in this interfaces, today we are going to discuss in detail about serial as well as SPI and I2C in the coming class also. And let me have a quick view about these particular things. In this module, we are going to discuss about these things like installation of these particular Arduino and Raspberry, as well as the interfaces, a serial and SPI and I2C. And coming to the main thing, which is the interfaces, serial communication. What serial communication was? UART. What UART was? It was a simple asynchronous serial communication protocol, which is used for short range data transmission. Got it, guys? And what kind of concept which is existed in serial communication in IoT? The basic concept was serial communication. In this serial communication, it was a method of transmitting data one bit at a time over a communication protocol. In this context of our Internet of Things, the basic fundamental method was we need to connect the devices for exchanging the information. Got it, guys? One bit at a time. This is how the serial communication will function. How it is going to work? Based on your data transmission. First factor is data transmission. Data is going to send sequentially bit by bit over a single wire. And synchronization. Here the devices must agree on a common data byte, which is a baud rate, to ensure the accurate data transfer. And start and stop bits. These bit signals the beginning and the end of a data frame for synchronization process. This is how the serialized communication will function. Data transmission, synchronization, start and stop bits. And also parity bit, which is an option bit for error checking, What are the different kinds of serial communications which are there? Asynchronous, synchronous. In asynchronous, no clock signal is going to be utilized. Here, the data is going to be transmitted at irregular intervals. Example was UART. UART stands for U for universal, A for asynchronous, R for receiver, or transmitter. UART, universal, asynchronous, receiver, or transmitter. Synchronous uses a clock signal which is going to synchronize the data transmission. That is what synchronous serial communication was. The best examples are SPI. SPI stands for Serial Peripheral Interface. Serial Peripheral Interface. S stands for serial, P stands for peripheral, I stands for interface. And also the third one, which is I2C, which is the best example for serial synchronous. I stands for inter and another I stands for integrated, and C stands for circuit. I2 means two I's, which is inter-integrated circuit. These two, SPI and I2C, are synchronous and UART is asynchronous. These are the two different types of serial communications. What are the advantages of using this serial communication? The main advantages of using this serial communication was it is cost effective and it is simply implementable and it has long distance transmission and it is a low power consumption. Coming to cost effective, which requires only few wires compared to parallel communication, whereas it is very easy to design and implement compared to complex protocols. And also the long distance transmission, which is suitable for connecting devices over long distances, and low power consumption, which is ideal for battery power devices. And coming to the next factor, which is common serial protocols in IoT. What these common serial protocols are? UART, which is widely used for simple low-speed transmission of microcontrollers and peripherals. Coming to SPI, which comes under synchronous, as well as I2C. These two comes under synchronous. UART was asynchronous, where SPI, which is faster than UART, oftenly used for connecting sensors and actuators, when I2C is suitable for connecting multiple devices on a shared bus. Example was temperature sensor. This is a sensor which might be used in UART interface also to send the temperature data to microcontroller. When this microcontroller is going to process the data and transmits to a cloud platform via Wi-Fi. In the essence of this serial communication, which provides a reliable and efficient way for IoT devices for exchanging the information and also for putting a foundation to various kinds of IoT applications about these serial protocols. Coming to serial communication, UART. In this UART, we are having UART protocol structure where this universal asynchronous receiver or transmitter is a serial protocol which transmits the data one bit one time at a time. In a specific time, the one bit information is going to be transferred. For suppose I have given one time which is 1 minute. In that 1 minute, only one bit of information has to be transferred. If I give 1 second, in that time, only one bit as information is only has to be transferred. This frame consists of different elements such as start bit, data bit, parity bit, stop bit. These are the different things which are consisted. Start bit, which is having a always logic 0, which indicates the start of a data frame. Data bits, which contains the actual data which has to be transferred. The common length was 5, 6, 7, 8 bits. The common length is going to be 5 bit or 8 bit or 6 bit or 7 bit. This was the common length for data bits. Data bits are the things which has the actual data which should be transferred. Coming to parity bit, which is an optional bit for error checking, which can be odd, even or none, whatever the things are. Coming to stop bit, which is going to always use a logic which is indicated at the end of a data frame. 1 or 2 bits per can be utilized. Serial communication. In this data transfer, we have seen the previous thing, protocol, and here the data transfer, how the synchronization was. Here, while transferring the data, as I told you, it is a asynchronous thing, and here the synchronization will be done with the help of transmitter, and receiver must agree the baud rate, which is bit rate, and also start bit. The transmitter is going to send a start bit to the signal, and also it is going to begin the data transmission. Data bits, in the here, the data bits are going to transfer LSBs, which is least significant bit first. Parity bit, if it is enabled, the parity bit is going to transfer and check the errors. Stop bit, the transfer is going to send 1 or 2 more bits to indicate the end of the data frame. And ideal state, this line indicates the logic 1 and starts for the next bit. And coming to the flow control, how the flow control in UART was. The flow control is essential to prevent the data loss when the receiver can't process the data as fast as the transmitter can send it. Here the receiver is not able to process as fast as the transmitter is sending. Here there are 2 different kinds of things which supports by UART. Primary flow control methods, which is hardware control flow, and the one is software flow control. And hardware control flow, here we are using 2 additional lines. One is RTS, another one is CTS. One is request to send, RTS. Another one is CTS, clear to send. These are the 2 additional lines which we are utilizing. And here the receiver is going to send when request to send. When it is ready to receive, then only it is going to send. And when it is ready to send the data, the transmitter is going to asset with CTS. Right? This is how a reliable flow is going to be done with the help of this hardware flow control. Now we will see software flow control. Here we will use special characters such as X on, X off to signal flow control. The receiver send X off to pass the transmission. Receiver refuses transmission means after receiving X on. Here less reliability of hardware flow due to the potential timing issues. This is how the things are. See the things, how the data is going to be processed, how the things are existed in UART. Here, start by detecting the transaction logic 1 or logic 0. Here, the start bit is transmitted the word data with priority bits X on, X off. This is how the things are. This was the UART frame structure, personal data. Here, I am showing you the structure with start bit, data bits, parity bit, as well as stop bit also. This is parity bit, this is stop bit, and this is the word data, and this is a start bit, and this is sample stop bit, and this is start bit. And these are the things which are existed in this UART frame. And by understanding the structure, the data process, and the flow control mechanism of UART, you are going to utilize this particular transmission in your projects very efficiently, and you can implement different kinds of IoT applications in your future projects. And coming to the next factor, which is advantages and disadvantages. What advantages we will get by using UART? What disadvantages we will get by using this UART? Advantages are simplicity. Simplicity plays a major role in UART. Why? Because it is easy to implement and easy to understand. Low cost, which requires minimal hardware components, and it is flexible, which can be used for various data rates and which is widely supported also by many microcontrollers and many peripherals. And it is also a long distance communications. These are the advantages of using UART. And now we'll see the disadvantages of using UART. Low data rate. Here the between protocols to protocols like SPI, I2C, UART have less compared to those two. Why? Because it is a synchronous transmission, whereas those two are synchronous transmission. So the data rate will be a little bit low. Suspectably, noise will be there by using UART. Why? Because it is a serial protocol, very suspectable noise and inefficient use of bandwidth. Why? Because there are start and stop bits of transmission. In summary, I can say you one thing with these advantages and disadvantages. You know how much effective it was, how much priorities has been given, and in which areas it was low, so that you can implement in your projects. And coming to the use case of using this thing, particular UART, see the things: universal asynchronous receiver or transmitter, which stands for expansion of UART. UART stands for universal asynchronous receiver or transmitter, which is a versatile protocol with numerous applications in IoT. Here, the common things are sensor data acquisition, which is used for connecting low power sensors, which consumes only battery operated sensors, and simple data transfer. Here, many sensors like temperature, humidity, and pressure controls are going to be utilized. Actuator control. Here, actuator is going to be controlled by using simple actuator such as sending commands like motor, servos, relays. And coming to low cost solutions. Here, for actuators, here the UART will offer low cost options in it. This is how the use case is. And what are the different types of communications which are utilized in these modules? The communications are GSM, which is GPRS, and GSM, Global Service Mobile, which is GPRS is the one UART is commonly used in interface. And by using these modules in cellular network, we can create wonders. And coming to GPS, Global Positioning System. And in these modules, we are acquiring the location of the particular person with this GPS modules, which offer users UART communication only. Coming to Bluetooth models. In many of the Bluetooth models, UART is used for data exchange transmission. And RFID. By using RFID, UART is going to read RFID readers, whereas credit card, debit card readers, RFID readers are there. If you swipe in it, automatically our data is going to be transferred, and we'll use in debugging and deployment. Here we are having two different things. One is serial console, another one is data logging. Serial console was the thing where we are debugging the microcontroller and monitor system behavior. Coming to data logging, we are going to collect and store the data for analysis, which can be achieved by using UART. And the other applications which are utilizing this UART was human machine interface, HMI, and which is used for simple text-based interactions only. And coming to data transfer between microcontrollers, which is used for establishing connection between different microcontrollers when an IoT system is utilized. In summary, I can say you one thing: with all these three aspects, by considering the use cases, by considering the advantages and disadvantages, by considering the UART main theme, I can say you one thing: UART, which is best for simplicity and which is low cost, which is widely available on popular choice of IoT applications, which gives us, which it might not be the highest performance option, but it often provides a practical and efficient solutions for n number of use cases, guys. And coming to the next factor, which is SPI communication. SPI, asynchronous serial communication protocol, which is used for short distance communication, which is oftenly used for high speed data transfer. Compared to UART, this is a little bit high speed. Why? Because it is synchronous. And coming to SPI, which stands for S serial, P peripheral, I interface, which is going to operate in a master-slave configuration, which means one device is designated as the master and the other is controllable to the communication, and one or more devices are going to act as slaves. Here, master and slave. Master is the thing which is initiating the data transfer, which is generated by clock signals and controls the chip selected lines. Slave, which responding to the master commands. According to master-slave architecture, guys, master is the one who is giving commands, slave is the one who is responding to the commands as requested. This is how this SPI protocol is going to function. And SPI clocking structure. SPI is a synchronous protocol which is used for clocking signal to synchronize the data transfer. Here S clock. Here the S clock is generated by master, which is connected to multiple things. Clock signal, S clock. And coming to rising or falling edge. Data is typically sampled with rising or falling edge by based on its terms and things, which is dependent on device configuration, guys. And coming to the next factor, data transfer. In this data transfer, SPI is going to support full duplex communication, which is a meaningful data which can be transmitted in both directions simultaneously, which is MOSI, master out, slave in, where the data from the master to the slave, and MISO, master in, slave out. It is complete vice versa, data from slave to master. The data transfer process involves master assets in the chip select line, which is a desired slave. Master generates clock pipe of SCLK line, and on each edge of these MOSI, which is a master out, slave in, and master in, slave out line, which captures a bit in both the accesses. And coming to the data sensor in serial form, the most significant bit, MSB, is typically sent first. And coming to the D assets, this CS line, where the end of the communication with the slave. This is how the things are, master and slave. MOS, master out, slave in. And here also the same thing. And here, master in, slave out. Slave is going to respond here. That's why arrow mark is showing towards master. And here, master out, slave in. So, slave is receiving. Here, SCLK, S clock, serialized clock, which is sent. And here SS and CS both are presented. So automatically this was a diagrammatic representation for communication purpose, which shows you an image of SPI communication process between master and slave. These are the 3-4 things which are happening in master and slave. Key points such as, which is a SPI, we can say in a single word, high speed protocol compared to UART, which requires synchronization between devices. And here the multiple slaves can be connected to a single master with asynchronous selected lines. And the advantages and disadvantages compared to UARTs. Here the advantages such as high data transfer rate. The first one is high data transfer rate. Coming to this, here SPI can achieve significantly faster data transfer rate compared to UART. Full duplex communication. Here, compared to master and slave, the data is going to be transferred simultaneously. And it is very simplicity. SPI is simple protocol structure without stop and start bus of priority checkers. Efficient usage of bandwidth, which plays a major role. These are the advantages. Coming to the disadvantages in this SPI, the disadvantages are shorter communication distance. It is only used for limited communication distance only. Master-slave architecture, it is less flexible than UART. Why? Because master and slave peer-to-peer fashion design, and it is also having more complex wiring. It requires pins of data, so data, clock, chip selection lines, multiple things are there. So it is a complexible wiring compared to UART, and there is susceptibility of noise. There is no sensitive to noise compared to UART. In summary, I can say you one thing of these advantages and disadvantages. It requires high-speed data transfer between master and few slaves within a short distance. UART is suited for lower data ranges and longer ranges, which is more flexible on topologies. And coming to the use case in this particular SPI was, it is well suited for various IoT applications due to the high speed or efficiency. I will show you some use cases. Sensor data acquisition. This was the first use case which I want to show you. In this sensor data acquisition, high-speed sensors are there. Multiple sensor integration was also there. In high-speed sensors, we are going to acquire the data from sensors that generates the data and high rates, which are accelerometries, gyroscopes, and magnetometers. Coming to multiple sensor integration, here multiple sensors are going to be connected to microcontroller for simultaneously data acquisition. And actuator control, motor control will be there, LED drivers will be there. In actuator, motor controllers, driving motors, especially in the applications such as precise, high speed, we need to monitor, right? For that, actuator control has to be done. And coming to LED drivers, which are going to control multiple LEDs and LED strips with high refresh rates. These are the different use cases I am showing. And coming to DAC and ADC. digital to analog converters and analog to digital converters, which having various applications between these communication with peripherals such as flash memory, which is a flash memory devices for data storage, display controllers for driving, like LCD or OLEDs, wireless communications, SPI using these wireless communications, and some more applications which are helpful are image sensors, audio coders. Image sensors are the one which generates CMOS image sensors. Audio codecs are the ones which is used for digital audio processing, especially at the time of video buffering streams. We are using this. The major benefits, the key benefits of using this SPI, the applications are high data transfer, which enables the real-time data processing for signal, and efficient communications, which reduce the CPU compared to the other protocols. Multiple device support, which allows you to connect to multiple devices. In conclusion, SPI is a valuable tool which is used for data transfer successfully. That's it, guys. We'll meet in the next class along with I2C communication protocol and the finalization of these installations in detail in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.